Good afternoon. I'm right before your lunch. My name is Susan Wu. Is it too loud? Okay. I'm from the Networking and Security Business Unit. I'm the Senior Product Marketing Manager for Service Mesh. I also handle open source networking in NSPU. So there's a commercial product called NSX Service Mesh, which is a management plane built on top of Istio and Envoy. So here in the code booth, we're talking about the open source, not the commercial product. Let's see. So let me skip. How many folks are in software development? Okay, yeah. So myself, I used to be in Java, and now I'm a newbie in Go. So many years ago, people were building monolithic applications. So in my old product team, there were 300 engineers, and they were all using the same IDE. We thought we were bad. We checked in code once a week. And then when I went to microservices, I worked at .cloud, and people were checking in every hour. And so you can see the advantages of microservices very quickly. These small pizza teams can decide on the programming language as well as the backend. And as long as these services talk together, you can rev the services at your interval, and you can implement changes, and you can roll back at your interval. So that's the reason why many people are using microservices today. It didn't work in SOA because a lot of it was kind of macro services. But in SOA, it didn't work, and I was in there as well. The reason that it didn't work is the premise was reusing a lot of that code, but in reality, it really wasn't used because the services included the business logic, and that made it very tough for app teams to actually reuse it. Were any folks exposed to SOA before microservices? Did you get a lot of code reuse? Okay, so it worked for you. When I was doing e-commerce, very few of the modules were reused. So what we found, though, is when you started breaking the application into tens and thousands of pieces, every team had to figure out how to connect the services. And they would have to know a little bit about networking, and they had to know about security. And in my experience as a product manager, we didn't find a lot of people that had networking background as well as distributed systems background. And so what would you do, right? That's the proposal. So we propose that you use a layer of abstraction, that the developers would all work against a common abstraction. It's still pretty complicated because the Istio project is not more than 2 years old, but it is the right idea. In Go, there's a notion of annotation and everybody using the same abstraction. I guess similar idea here. Here today, I'm just going to go quickly on the Istio service mesh architecture, but I'll spend a lot more time on use cases. And if for those who are using Istio, kindly share your experience. I mean, that's the reason we're here. We're here to learn from each other. So as I explained, service mesh, there's two elements. There's data plane and then control plane. In the data plane side is actually putting in what's called a sidecar proxy, which is actually a container, into that pod, injecting that sidecar proxy into the pod. And once you have that, you can implement these services, layer 7 type services, like load balancing, health checks, circuit breakers. You can collect rich telemetry from that, and you can also do service discovery once you've injected that sidecar container into the pod itself. But overall, it's actually two levels. So we talked a little bit about that data plane. So this is the Envoy, which is like a load balancer. It actually provides the capability for you to have service-to-service communication with encryption. So it's actually all or nothing, with encryption or without encryption. I mentioned briefly about the NSX Service Mesh product. With that product, we've implemented the capability for you to use it in two modes. So you could selectively encrypt the service, or you could leave it unencrypted. But in the open source, it is either encrypt or not encrypt, all or nothing. And then in the data plane side, you have functions like configuration management, where you define the configurations. You have the proxy of the policies, where you could apply the policies across user policies across the services. So Istio is primarily responsible for services, but in an application, you have interactions with users and data. And so that's where kind of our commercial product is going beyond just the service-to-service communication. But in this case, you use the Istio components to define your configurations that governs the traffics and the rules, and the policies where you manage the policies and enforce the access controls on the services. And lastly, the certificate management. A lot of developers complain about having to rotate certificates. And so using something like this can handle the lifecycle management of your certificates. So this is actually like a overview of what needs to be defined. And I have an example of how to define the destination rules. So I'll use the example of the circuit breaker later. And I also have an example with a YAML file. But you start with like the gateway, and like you define the URLs where it's going. And then the virtual service is where do you want to send this traffic. And then the destination rule is what additional rules you want to apply. So I'll use the example of a circuit breaker later to illustrate that more clearly. So in distributed tracing, this is one example, but on the public web, they talked about a bank called Monzo Bank. And I think the statistics is there's 150 developers. Each developer is responsible for 100 services. So then you can see tracing becomes kind of like a nightmare. And the other reason that tracing is a nightmare, if you use something like Jaeger, is because you have to use language-specific libraries to implement your tracing. So we have found that there's just there's a plus side of using tracing, then there's a little bit of a minus side of using tracing. And so the advantage of tracing is being able to trace through the services. And the disadvantage is having to use the specific language, specific libraries. So in microservices, you can envision that some services are written in Go, talking to a different backend, like say MySQL or MongoDB, and then maybe another team might have chosen something like Node.js, and then maybe using a different backend. But when they implement the tracing, they have to choose the right specific library. And let me show you. And so this shows the example without choosing the right library, but with you abstract that into the sidecar proxy, and you wouldn't have to worry about finding the right library. Another example is actually doing traffic management. So in software development, there's teams testing new releases. Kubernetes itself, if you just use Kubernetes normally, the kube proxy would evenly distribute your traffic across the pods. And that's okay. But if you were to add a pod, it would do the same. It would evenly distribute the traffic across the new pod, so 25% going to the new pod. But if you were looking to test new software, so for example, I might be testing release 1 of a software, and I want to send maybe the majority of my traffic to the existing software. And then I want to test release 2. It's like a new release. I don't want to affect a lot of users. So with something like Istio, I can define the traffic, the amount of traffic that's going to that new release. So that's one example of using Istio Service Mesh for software testing. Another way to do this is actually with traffic steering. So because Istio allows you to define some rules in the YAML, I have an example to show you, then you can you can examine, say, maybe users coming from a certain geography, you want them to send them to a certain release. So for example, back to the software testing, on that release 2, maybe I want to test IE folks that are using Internet Explorer, which is not nobody. Actually, is my example from my other engineer. Very few people use IE, actually. So maybe you want to test with like Firefox. So, hey, they're coming from a particular region and they're using Firefox. Browser testing, I used to work with another piece of software. We use Selenium to test a lot of browser combinations. So this could be a popular use case, right? I would use Selenium and then set up the different test beds. And then maybe I would be able to test the software release 1 or release 2 and be able to direct the specific amount of traffic to, say, the new releases. Was there a question?
Does that require Selenium to integrate directly with Istio?
No. So Selenium, when we use Selenium, we actually put the Selenium into like a container. Then we actually define the combinations. We also containerize them. Yeah. I just use that example because I think a lot of people still use Selenium for mobile browser testing today. So circuit breaking is a really interesting concept. So I guess it's like electricity. If you're getting a surge, I guess that circuit would just stop. Same idea. If you have a distributed denial of service, a lot of requests coming in, then using Istio for circuit breaking, you can stop that so that it doesn't go to, say, an unhealthy node. So I took the example. You can implement that in the YAML file. So for example, if the host is like getting 503 errors, you shut it down. Don't send any more traffic to that host with the 503 errors. And actually, it's not too difficult to configure the YAML file because most of this is pre-done, and you just it's pretty easy actually, pretty straightforward. The last use case is network encryption. So in traditional client software, client-server paradigm, you're all using the same security and networking models. But in a microservices, every service needs to connect and secure communication between the services. So there's a risk if it's unencrypted of what's called like a man-in-the-middle attack. And so using the encryption that I spoke about earlier, in the data plane, you can implement the MTLS to secure the service-to-service communication between two. And then you can also rotate your certificates so that it can't be hacked and easily compromised. So there's my Twitter and my GitHub. You could check out my stuff if you want. Was there any questions?